In this video, we're going to solve trigonometric equations. Now, notice that for these particular examples, the domain is from 0 to 2 pi. So that means that we're only going to use the values on the unit circle. So let's start with this example. 2 cosine squared equals to 1. The first thing I want you to do is to solve for cosine, as if cosine were its own variable. So what would I need to do? Well, opposite of pandas, we will divide 2 first. You're left with cosine squared of x equals to 1/2. Then we square root cosine of x equals plus or minus the square root of 1/2. Okay? Now it's not obvious what the value is, so we need to simplify. So plus or minus square root of 1 divided by square root of 2. Remember that the square root of a division is the division of the square roots. Now, what is the square root of 1? 1. Okay, now we rationalize. So we multiply by radical 2 over 2, top and bottom. So we got radical 2 over radical 4, which becomes plus or minus radical 2 over 2. So the question is, what angles inside the unit circle will produce plus and minus radical 2 over 2? Well, all the angles that have denominator of 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that will be your answer. The next problem, you will need to solve a quadratic equation. So for example, I usually tell my students, hey, take y equals sine of x. Okay? Then this equation becomes 2y squared plus y equals 1. Then you have a quadratic, so you will subtract the 1, so you have 2y squared plus y minus 1 equals 0. Here we use the x method or the cross method. Okay, a times c on top, b in the bottom, a, b, c. A is 2, c is negative 1, so negative 2. B is positive 1, so 2 factors of negative 2 that when you add them gives you positive 1. Well, the answer is going to be 2 and negative 1. So then we substitute b by these two numbers. So you have 2y squared plus 2y minus, let me erase that, minus y minus 1 equal to 0. We factor the first two and the last two. What can we factor between 2y squared and 2y? 2y. You're left with y plus 1. What can you factor between negative y and minus 1? Negative 1. You're left with y plus 1. Notice that this y plus 1 and y plus 1 are factors. Therefore, we can factor it out, and we are left with y plus 1 times 2y minus 1. Okay, 2y minus 1 equals 0. Now the zero product rule says that if two things are multiplying equal to 0, that means that one of them is equal to 0. So y plus 1 equals 0, or 2y minus 1 equals 0. We solve for y equals negative 1. Here, 2y equals 1. We divide by 2, so y equals 1/2. But what was y? We define y to be sine of x. Sine of x equals negative 1. Sine of x equals 1/2. The question is, what x value or what angle on the unit circle will give you sine equals negative 1? And the answer will be 3 pi over 2. Now, what angle on the unit circle will produce sine to be 1/2? Well, we have two of them. We have pi over 6 and 5 pi over 6. And those are your answers. Now this one involves a little bit more trickery. Okay, let's use a different color here. Well, notice that we will need to factorize something in order to use the zero product rule. So what I'm going to do is I'm going to factor from these two 2 sine of t. And that's left with cosine of t plus 1. And then from these two, I'm going to factor negative 1. I'm left with cosine of t plus 1. Now notice again, just like the x method, this is a factor and this is a factor of 2 sine of t and negative 1. So this becomes cosine of t plus 1 times 2 sine of t minus 1 equals 0. So now, zero product rule, I have cosine of t plus 1 equals 0, or 2 sine of t minus 1 equals 0. We subtract the 1, so cosine of t equals negative 1. Just add the 1, so sine of t equals 1, and then divide by 2. So sine of t equals 1/2. Again, what angle will produce cosine to be negative 1? Well, the answer is pi. What angle is going to produce sine of t equals 1/2? The answer is, again, pi over 6 and 5 pi over 6. And that will be the rest of the work. If you like the video, subscribe to Mr. Bonet. Visit my website, www.motival.com. And if you have any questions, let me know in the comments below.